Welcome everybody. This is topic 1.3 for AP Computer Science A AP Daily. We're getting into topic 1.3, which is expressions and assignment statements, and this is video 1 for our topic. In this video, we are going to look specifically at how we can evaluate arithmetic expressions in program code. You know, a lot of what we do in programming involves arithmetic operations, being able to add things, multiply things, and do actual calculations. So there's actually a lot that's going to show up in this video. Evaluating arithmetic expressions in program code. Specifically, we're going to look at what a literal is. We're going to look at the 5 arithmetic operators: addition, subtraction, multiplication, division, and maybe a new one, modulus. We're going to talk about the fact that we're going to end up with ints and doubles depending on what it is that we're working with in our calculations. So we'll come back and we'll unpack all of this at the end. I wanted to go ahead and jump right in. Back in topic 1.1, we talked specifically about a string literal. Remember, we said a string literal is anything that's enclosed in double quotes. I can represent a literal number, the source code representation of a fixed value 3, but I can also represent it as a string literal. And I wanted to point out that those are two totally different things. We have to be careful about how we use numeric values depending on what it is we're going to do with them. So for example, when I write a little program and I say system.out.println 3, it's going to show up as a 3 on the screen. When I do system.out.println the literal value, string literal 3, it also shows up as a 3 on the screen. So at that point, it doesn't look like there's much of a difference. The problem comes when we want to start doing actual arithmetic operations. So notice now if I say I want to do system.out.println 3 plus 3, it's going to add those two values together and it's going to give me 6, which is what I would want if I'm working with numbers. If I try and add the string literal 3 and the string literal 3, that's referred to as concatenation. You'll learn more about that in 2.6, but the result is that I end up with 3 3s. So it doesn't do quite what I would anticipate it's going to do if I'm using them as string literals instead of just regular numbers. So that's the first thing I wanted to point out. There's a difference between a literal and a string literal. A literal is a numeric value. It's a representation of a numeric value that I can now do arithmetic operations with. There are 5 basic arithmetic operators in Java. There's the plus sign for addition, minus sign for subtraction, multiplication, division, and then there's this new one, and this is not percent, this is modulus. And what modulus does is it gives us the remainder of a division problem. So if I'm doing 8 modulus 4, 8 divided by 4 would be 2 with a remainder of 0. So 8 modulus 4 is going to give me 0. We'll talk more about that in a minute. The other thing I wanted to be careful to point out is because we're working specifically with ints and doubles in the AP subset, those are specifically the data types we're working with. If I'm doing operations that involve ints, my result is going to be an int. And that becomes kind of an issue when I'm doing division. If I do 1 divided by 2, I'm not going to get 0.5. I'm going to get an integer, which is going to give me 0. I'm only going to get the integer part. There's no rounding involved. If I do operations that involve doubles, then the result's going to be a double. And if I mix them, if I do mixed type operations, we always go with whatever the bigger data type is. Double is an 8-byte data type and an int is a 4-byte data type. So if I'm combining ints and doubles, the result is going to be whatever the biggest data type is. I'm going to end up with a double result. Okay, so let's look at some examples of how all this works. The first thing I really wanted to get into was an explanation of what modulus is and how modulus works for us. Let's say I take 5 divided by 17, and I want you to think back to when you were in maybe elementary school where you learned to do long division. When we would do 17 divided by 5, 5 goes into 17 3 times. So now I would multiply the 5 and the 13 to get, the 5 and the 3 to get 15, and then I would subtract and I would have 2 left over. So I end up with 3 with a remainder of 2. Well, if I do 17 divided by 5, again, because I'm using integers, I'm going to get an integer result, which means in Java, 17 divided by 5 equals 3. Okay, I'm using integer values, so I get an integer answer. If I do 17 modulus 5, that's going to give me the remainder of that division problem, which is going to give me the 2. So that's where we calculate modulus from. Okay, modulus always gives us the remainder of a division problem. Now, to kind of demonstrate the fact that we've got, integer operations and that an int plus an int gives us an int, I wrote a little program here that's going to display some integer operations. 17 plus 5 is 22, 17 minus 5 is 12, 17 times 5 is 85, 17 divided by 5 is 3, 17 modulus 5 is 2. Notice there are no decimal places in here anywhere. There's no decimal point. I'm getting strictly integer answers. If I change this and make these double values, which means now I'm using decimal values, okay, I'm doing operations that involve doubles, which means I'm going to get double answers. So now I'm not just getting 3, when I do 17 divided by 5, I'm getting a true decimal answer. 17 divided by 5 is 3.4. It's because I'm using double values that I'm getting a double answer, and I can accommodate that decimal place. The other thing I wanted to show is that if I do mixed type operations, in other words, I include a double and an int, we're still getting double values over here, even if it works out to be an integer result. So 17.2 times 5, even though that works out to an integer value 86, because I'm using doubles, it's displaying as a double. It's going to specify that there's a decimal place there, even if that decimal value is 0. So keep in mind that there's a difference between doing integer operations and double operations. If I'm using a double value anywhere in my operation, I'm going to end up with a double result. Okay, that's our video number 1 for topic 1.3. The key takeaways. We can evaluate arithmetic expressions in program code. Okay, that's our main learning objective for this video. The little essential knowledge pieces are a literal, which is different than a string literal. Okay, a literal is the source code representation of a fixed value. Arithmetic expressions, at least in the AP subset, include expressions of type int and double. There are 5 arithmetic operators: addition, subtraction, multiplication, division, and modulus. And as long as I'm doing integer operations using 2 integer values, I'm going to get an integer result. If I'm using double values, I'm going to get a double result. Okay, thank you for watching the video. Please continue to watch the videos that follow. I hope everyone has a great day, and I'll see you the next time.